Hello everyone, today in this video we'll be covering the dot and cross diagrams for covalent compounds. Now this is a very important portion of covalent molecules, so let's look into it. We'll start off with simple structures like hydrogen molecule. So H2. Now we know that hydrogen has one valence electron, right? I will denote it by a cross. So the valence electron of the left hydrogen is in this subset, right? Now the electron of the right hydrogen is also drawn into this subset. So you can see that now the left hydrogen and the right hydrogen, both of them are sharing two electrons between themselves. So therefore their duplet is complete and they have a stable valence shell. Both of them do. So this is a stable molecule, right? Now let's look at CH4, which is methane. Now in methane, we can see that we will have each hydrogen would present one electron, one valence electron. So let's draw that. Now we know that carbon has 4 valence electrons. So let's denote that by a cross. Now each of the hydrogens have 2 electrons and the carbon has a total of 8 electrons if you look at it, right? So the carbon is also stable and all the hydrogens are also stable. Therefore, all of them have stable duplets and octets, and this is a stable molecule. This is how we draw the dot and cross diagram. Now, this is when there is a single covalent bond, right? But what if we have a double covalent bond? You can see that these two are double covalent bonds, right? Now let's look at their structures. We know that carbon has 4 valence electrons, so it can give 2 electrons to each of the oxygens, right? We also know that oxygen has 6 valence electrons, so it needs 2 electrons, right? Therefore, the carbon has fulfilled its duty and it has given 2 electrons to each of the oxygens. Now, each of the carbons, the carbon needs a total of 4 electrons. So each of the oxygens would also give 2 electrons. As you can see, I have drawn them. Now remember, the oxygen has a total of 6 electrons. If it's given 2 of its electrons, we can draw the rest over here, right? So we have drawn 4 electrons outside. These are called lone pairs. What are they called? They are called lone pairs of electrons because they are not involved in bonding. Keep that in mind. Now water. Water has 2 single covalent bonds. Single covalent bonds mean that each of the molecules will only share 1 electron. It will contribute only 1 electron. So hydrogen only has 1 electron, so it will only contribute 1 electron. Oxygen will also contribute 1 electron because that is all that hydrogen needs. So now the hydrogens have stable duplets. The oxygen has a total of 6 valence electrons. It has given away 2 of its valence electrons, so it has 4 of its electrons left, and these are its 2 lone pair of electrons. So we say oxygen has 2 lone pairs in the molecule of water. Now let's move on to some more examples. Nitrogen. Now nitrogen has a triple covalent bond. It's like this. So triple covalent bond means that each of the nitrogens must share 3 electrons. So it would be something like this, I believe, right? So if a nitrogen has 5 valence electrons, 3 of its valence electrons are used up, so we would draw the other 2 in the valence shell, and nitrogen has 1 lone pair of electrons. Now PCl3. Now we can also draw the circle structure for the compounds, right, for dot and cross compounds of covalent molecules, but we can also draw this way. Okay, now let's look at how this is drawn. Now we know that chlorine has 7 valence electrons. It needs 1 electron. Phosphorus is in group 5, so it needs 3 valence electrons. It has 5 valence electrons. So phosphorus can give one of its valence electrons to each of the chlorines, right? And chlorine can give one of its valence electrons to the phosphorus. Now, phosphorus has given 3 of its 5 valence electrons, so it has 2 more. So let's draw those over here because those are its valence electrons, right? Chlorine has given one of its valence electrons, so chlorine has 6 more left, so we would draw them around them. So let's just draw all of them around chlorine. So instead of drawing the circles, you could also use this alternative. It may look neater, if you would say, and we can clearly see that all of the molecules, the chlorines and the phosphorus, all of them have stable octets. They have 8 electrons. Now ammonia. In ammonia, each of the hydrogens can only contribute 1 valence electron. So let's draw them. And the nitrogen has 5 valence electrons. It should only give 1 valence electron to each of the hydrogens because that is what it is required. If it gives 3 electrons, it will have a lone pair of electrons left. And now you can clearly see that the nitrogen has a stable octet and all the hydrogens have a stable duplet. Now the last one is a special case, PCl5. Now you will see something special about this after I am done drawing. Similar case, chlorine has 7 valence electrons. It will contribute 1 valence electron to the phosphorus, right? So let's just contribute 1 valence electron. Now phosphorus is in group 5. Chlorine needs 1 valence electron. So phosphorus will give 1 valence electron to each of the chlorines, right? Now phosphorus has 5 valence electrons, so it's given all of its valence electrons away, so there are no lone pairs. Chlorine has 7 valence electrons. It has given 1 valence electron, so there are 6 valence electrons left. So this is how it looks. Now if you see, all of the chlorines do have 8 electrons around them, so they do have a stable octet. But if you notice, the phosphorus has 10 electrons around it. 5 of the electrons are phosphorus's own valence electrons which it has shared, and 5 of them are chlorine's valence electrons which it has shared with phosphorus, right? So there are 10 valence electrons. Now generally phosphorus would need only 8 valence electrons to be stable, but it has 10 now. This condition is called an expanded octet. This is important. In this what happens is, let's look at what happens. Phosphorus has the atomic number 15. Its electronic configuration is 1s2, 2s2, 2p6, 3s2, and 3p3. Now what actually happens is that the 2 extra electrons, they go into the 3p subshell. After 3 electrons are transferred to this, the 3p subshell gets full and it becomes 3p6, but the 3d orbitals are empty, right? So 2 of the electrons go into the 3d orbital, So that is what basically happens, and therefore we call this an expanded octet, right? And that is all for the structure of covalent compounds. Thank you.